Good morning. I welcome you all for lecture number 2 of the course Experimental Aerodynamics. In the previous lecture, we had the discussion on the need for experimental methods in fluid mechanics. Then we also looked at the objectives of experimental measurements in fluid mechanics. In this lecture, we are going to look at the different categories of experimental measurements or measurement techniques. Of course, in fluid mechanical experimental methods, we use large number of measurement techniques to understand the flow behavior. The experimental techniques or experimental investigations used in fluid mechanics can be broadly classified into three types, namely direct measurements, analog measurements or methods, and flow visualization methods. Direct measurements is otherwise called as the conventional experimental method, where we use wind tunnel as the experimental device. Right. We will take the direct measurements first, that is wind tunnel studies. Wind tunnels are used for a number of experimental investigations. For example, wind tunnels are used in the area of fundamental research. In this image, you can see four different aerofoils, right? These aerofoils are different from each other in terms of the flap angle. You can see the first aerofoil is having 0-degree flap angle. Second, third, and fourth aerofoils are respectively have the flap angles of 5, 10, and 15 degrees. So these aerofoil models with different flap angles are kept in the test section of the wind tunnel to understand the flow behavior and to measure the forces like lift and drag and the effect of the flap angles on the forces exerted by the flow. So what the aerofoil you are looking at in this image is Clark Y aerofoil. So this is one of the examples of fundamental research. Next, industrial aerodynamics is another area where the direct measurements or wind tunnel studies are exhaustively taking place. In industrial aerodynamics, we use wind tunnels to find out the flow behavior over tall buildings, large bridges, automobiles, even locomotives, and so on. So in this picture, you can see an automobile placed inside the wind tunnel. Over the automobile, parallel streams of smokes are passed over, and the flow pattern over the automobile, that is the race car, is visualized with the help of the wind tunnel. So these are few areas where the direct measurements are exhaustively used. Next, in fundamental studies, basically we use the scaled models of aircraft components, automobiles, buildings, and so on to determine the forces exerted by the flow on these scaled models. And these forces, such as lift and drag forces acting on the model, can be calculated using the law of similitude. You can see an equation, a familiar equation, where the force is equal to 1 by 2 rho v square s cm, where rho is the density, well, v is velocity, s is surface area or cross sectional area, and Cn is the force coefficient. The Cn can be either lift coefficient or drag coefficient. So if Cn is lift coefficient, then you will be calculating the lift force using this equation. And the force coefficient Cn is dependent on the flow Mach number and the Reynolds number of the flow used in the wind tunnel. In order to find out the force exerted by the flow on the scale models, we need to determine the flow field variables such as velocity, pressure, temperature, and density. So we need to measure these flow properties or flow field variables. In order to measure the flow field variable velocity, we can use different measuring instruments like pitot static tube, hot wire anemometer, or laser Doppler anemometer. Similarly, we can use surface pressure tappings or pressure transducers for the measurement of pressure, and appropriate instruments can be used for the measurement of temperature. Once the pressure and temperature are measured, the measured pressure and temperature can be used for the determination of density. For the measurement or determination of moments or forces, we can use specially designed balances in wind tunnel. So if I want to understand the behavior of the flow over the scaled model in a wind tunnel study, I need to measure the flow field variables using appropriate instruments. Next, we will look at the second method of experimental investigation, that is analog method. The meaning of the word analog is similar or equivalent. Okay, so let us look at how the experimental method is used here, or how do we find the flow behavior in this method. Here I have a problem, a flow problem. I want to investigate the flow problem to understand the flow behavior. In analog method, we select another flow system or another flow condition which is similar to the original flow problem or flow condition. Okay, actually we don't carry out the experiment under original flow condition. We carry out experiments under the similar or analogous flow condition or analogous flow system. Whatever the measurements we do in the analogous flow system, that measurements, experimental measurements can be used to understand the flow pattern or flow behavior of the original flow problem. Okay, so what is the similarity between the two flow problems, original flow problem and the analogous flow problem or similar flow problem, right? So we carry out the experiment on the analogous or similar flow problem, not on original flow problem. Whatever the measurements we take from the similar flow problem, those measurements are used to understand or to demonstrate the original flow problem or behavior of flow in original flow problem. The similarity is the governing equations. The governing equations of the flow problem, original flow problem, the governing equations of the analogous flow problem, these two are similar or these two are of same type, right? So that is why we are able to take the measurements of similar flow problem to demonstrate the flow problem, the original flow problem. Okay. Right. Some of the well-known analog methods for solving fluid flow problems are Elisha analogy, electrolytic tank, and surface waves in a ripple tank. For an understanding, I have shown here an image of a Elisha apparatus which works on Elisha analogy. Here, the original flow problem being studied is the behavior of flow or flow pattern of non-viscous frictionless flow over an aerofoil. So this is the original flow problem. Okay, non-viscous frictionless fluid flow over an aerofoil. That is the original flow problem. But I cannot experiment or do an experiment with the non-viscous fluid because all real fluids are viscous in nature. So I take another flow problem which is in some way similar or analogous to the original flow problem. So what I do here, how I do the experiment here in Elisha apparatus, I do the experiment of flow of viscous fluid, highly viscous fluid over the same aerofoil. So I take the measurements from, or the flow pattern is observed for the viscous flow over the aerofoil. This flow pattern or this flow behavior is used to demonstrate the flow of non-viscous frictionless flow over the same aerofoil. So this is the analogy, right? So here the original is non-viscous, but actually the experiment is carried out with viscous fluid. So whatever the flow behavior I get from the viscous fluid flow can be used to demonstrate the flow of non-viscous fluid over the same aerofoil because the governing equations for these two cases are of same type, right? So this is an example of analog method. Then the third method of experimental investigation is flow visualization method. In conventional experimental method or direct experimental method, in order to understand the behavior of flow, we need to measure the flow field variables such as pressure, velocity, and temperature at different points in the flow. Okay, and based on the flow field variables, with the help of some correlations or equations, we can say this is the force exerted by the fluid, like lift or drag, or this is the pressure distribution, or this is the direction of flow. Okay, so this is what we do in conventional or direct measurements. But in flow visualization, we don't make any measurements. Instead of making measurements, we directly capture the or visualize the flow pattern over a body, right? We observe the real flow pattern in the flow problem. Some of the popularly used flow visualization methods are listed out here. Smoke flow visualization using tubs, chemical coating over the body, interferometry, Schlieren and shadowgraph. These are some of the popularly used flow visualization methods. Here I have added some images of different flow visualization methods. On the left hand side, you are seeing a colorful image. It is the color shadowgraph method, flow visualization method. Okay, so this flow visualization method shows the flow and the formation of shocks over a blunt nose body. Okay, this blunt nose body is having a spike attached to the leading edge of the nose. You can see the formation of shock waves. On the right hand side, you have the image of Schlieren flow visualization method. So this is the flow coming out of the uh, aerospike nozzle and also the flow over the engine. Here, the dark thick lines indicate the formation of shock waves, right? So this method is called as Schlieren flow visualization method. Here, on the left hand side, you have a flow visualization method where air bubbles are introduced into the flow. You can see the vortex formed over the wings of the airplane, wings of the aeroplane. Okay, a sheet of light is passed over the body of the airplane at a particular cross section, and the image is captured to visualize the flow pattern, right? So the air bubbles are seen as white color dots or white color lines. Okay, so with the help of air bubbles, you can see the flow direction and flow pattern. On the right hand side is an automobile or car. You can see there are a number of pieces of threads or pieces of fabrics made of silk, okay, is attached at different points over the external surface of the car. And this car, when placed inside the wind tunnel, the flow of air over the car makes the tufts, the different pieces of threads, the tufts to orient in different direction. The orientation of tufts indicate the direction of the flow. So this is one of the flow visualization technique. So we have come to the end of lecture number 2. So in this lecture, we looked at the 3 categories of experimental investigation, namely direct measurements where we predominantly use wind tunnel as the experimenting device. Then the second experimental investigation method is analog method. And the third experimental investigation is flow visualization. Thank you once again for listening to this video lecture. We will meet in the next lecture.